Good day everyone. I am Engineer Romeo Concepcion Jr. and I was tasked to present our research project entitled the AgriBot System Disease Detection for Green Bean using CNN or EfficientDet with automatic sprayer. So for the outline of our presentation, we have our rationale, objectives, methodology, results in discussion, conclusion, and recommendation. So way back on the quarter 2 of 2020, so there is an increase of 0.5% in our crop production. But in quarter 3 of 2021, so there is a decrease in production, estimately negative 2.6% in our crops. So the researcher addresses these agricultural challenges in the Philippines so using a CNN model, or specifically the EfficientDet, that can detect disease of a plant and has an automatic pesticide spraying in our crops. One of the major problem is the shortages of farmer, wherein the farmer cannot monitor or don't have the time to inspect their crops in their crop field, resulting to significant losses for growers because of different diseases that may arise due to unmonitored crop. So the solution of the researchers is the use of agribots in agricultural industry, and for this technology, it develops a robust robotic system that captures sleep images that identifies diseases and applies pesticides accurately. And with this technology, so the system also streamlines harvesting with a crop transporter, and the AgriBot system effectively detects diseases, promotes sustainable agriculture, and benefits the agricultural industry in the Philippines and beyond. So the system uses data analytics for effective insights. So for the objective of this research, so first is to design and develop our system. Second is to test and evaluate the performance of our system. Next is to determine the efficiency of the project. And last is to determine the effectiveness of full system. So the general objective of this study is to develop an AgriBot system for disease detection in green beans. So using a CNN, or specifically the EfficientDet, and has an automatic sprayer. So the specific objective includes developing a robotic system for green bean and also a disease detection using a CNN, and also assessing the crop transportation of this system. So for the methodology, our concept is we have our input, process, output, and impact of our project. So researchers develop a robotic system for green bean cultivation, integrating disease detection, automated spraying, and crop transportation. And the researcher utilized a dataset of 4,000 green bean plants, so using images and trained images with the help of convolutional network. So the system's efficiency was evaluated based on the disease detection accuracy, effective spraying, and improved crop transportation. So with this framework, so the outcome is the early detection of disease for the green bean plants, and the possible impact is it will enhance the production or the yield of green bean crops, and it also improve the work condition and reduce the health risk for our farmers. So for the materials or tools that we need is we have this table enumerating the needed hardware. In the right side now we have our software requirements. So we have our Google Colab and the TensorFlow for testing and training of our data. So for the results in discussion, so the following are the final design of our project. So this is our AgriBot. that can detect different diseases of a green bean plant that has an automatic sprayer. Given you also the legend or the parts of our system. So the following slide is all about the circuit diagram of the design project, or how our project is connected with each other. So we have the legend here indicating a number. So we have a microcontroller here. We also have a camera, the servo motors, and so on. Then for the results, for the test, or for the accuracy of this detection, so in manual counting, there are 43 mosaics, 11 leaf mold, rust is 12, and there is a healthy plant considered, which is 11. And during test cases, so we have three different test cases here showing you the different results, and given you in the right table is the accuracy of each test, according to the diseases of plant. So the study successfully developed a robotic system for green bean cultivation, incorporating disease detection, automated spraying, and crop transportation. So the CNN with EfficientDet model architecture was demonstrated to improve the performance in object detection and classification. So the AgriBot system disease detection with an automated spraying and crop transportation features show promise on enhancing the agricultural practices and improving the productivity of the green bean plant. So for the conclusion and recommendation of our system, so by just following the requirement or the needed algorithm and using the technology advancement, so we can optimize the yield of our green bean plant. So based on the evidence presented, so the AgriBot system demonstrates its potential as an advanced technological solution for green bean cultivation. So the integration of disease detection, automated spraying, and crop transportation contributes to improve the agricultural efficiency and productivity. So these findings align with the growing need to sustainable agricultural practices and highlight the value of incorporating robotics and AI technologies into agricultural sector. So for our recommendation, so the researcher recommends to use a compact material and also to use an abundant data set for more accuracy of our test cases. And also, the researcher recommends to do comprehensive testing in order for us to optimize the effectiveness of our system. And our research project now visions also not just the green bean plant but also to detect all the diseases of all crops, in order for us to have an optimized crop yield in the future. So for the presentation, thank you. So that is our research project, and the following are the members of this research. So thank you.